So without wasting any time, let's start chemistry of class 11th. That is part 1. In class 11th, you have two books, right? Part 1 and part 2. So we will be discussing the entire part 1 in just one complete video. So without wasting any time and without skipping the video, please watch the video fully. And lot of students have been commenting to me that they want notes. So I can give you the notes, that's not an issue. But the problem is you have to make your own notes with your own hands. So when I'm teaching you, it's better that you watch the entire video and write the notes, whatever I'm telling you. Make your own notes. That will be more beneficial to you rather than me giving you the notes directly. So watch the video completely without skipping a single part of it and listen to me carefully, because this video is going to cover the entire part 1 of 11th standard. So sit onto your chair and get ready immediately. So there are these many chapters in part 1. So what all chapters you have? You have some basic concepts of chemistry, you have structure of atom, you have classification of elements and their periodicity. So whenever you start any subject, the first thing you are going to learn in every subject is basic concepts, right? So same way you have basic concepts in chemistry, then the basic thing in chemistry is the atom. So you will be studying about the atom, what is the structure of the atom, then classification of elements and periodicity, then chemical bonding, then you have states of matter, then you have thermodynamics, and then at the end you have thermodynamics, and then you have equilibrium. Okay, so get ready. We are going to start the first chapter, that is some basic concepts. In that you have mole concept. So the entire chapter basically talks about this only, the mole concept. So what is a mole? So just like you know what is a dozen means 12, right? So 12 apples means a dozen of apples, 12 bananas means a dozen of bananas, 12 oranges means a dozen of oranges, 12 bangles means a dozen of bangles, like that. Whenever you use the word dozen, it means 12. Like that, whenever you use the word mole means 6.022 into 10 power 23 number of anything. So it's a huge number, right? 6.022 into 10 power 23 zeros after that. So 600000000 like that, 23 zeros. So 60230000 like that, you have a very huge number. So this number is called the Avogadro number. It is also represented like this, Na. So you can see it is called Na. Okay, it's also called the Avogadro number, the 6.022 into 10 power 23. That number of substances is called a mole. So 1 mole of any compound, if you talk about 1 mole of chlorine, it has 6.023 or 22 into 10 power 23 atoms, or 1 mole of hydrogen has this much atoms, like that. So now, how do you find this number of moles? 1 mole means basically how much you know, right? So what is 1 mole basically? What amount of substance has 6.022 into 10 power 23? So basically, if the mass of your substance is equal to the molar masses are given in the periodic table. Okay, so molar mass means a substance which, if you take molar mass of a substance, it means it has 6.022 into 10 power 23. So if you take 1 gram of hydrogen, it has 6.022 into 10 power 23 atoms, like that. So that is called the molar mass. And so how do you find that number of moles? There are different formulas to find number of moles. So one method is you take the given mass and divide by the molar mass or the molecular mass. And another method is number of moles divided by 22.4 liters if it is any gas. So in case of gases, a gas at normal STP, this applies only at STP, okay? A gas at standard temperature and pressure has 22.4 liter. It occupies 22.4 liter volume. Then at 22.4 liters, it has 1 mole, a gas. 22.4 liter of any gas at STP has 1 mole. Okay, so how do you find number of volumes in liter? How much volume of gas you have? If you divide that by 22.4 liter, you will get the number of moles. And number of moles in terms of atoms will be how much? Given atoms by Na, Avogadro number, right? So if I have 6.022 atoms, you will divide it by 6.022, you get number of moles which is equal to 1, right? So you can see this drawing here, everything is given. So how do you convert moles to grams? How will you convert moles to grams? So to convert the moles into grams, you just need to, you can see here, you can look here. To convert the moles into grams, you need to multiply by molar mass. And to convert the gram into moles, you need to divide it by molar mass. And same way atoms, you can see, same way for atoms, you need to multiply the moles with 6.022, you will get the number of atoms, and you divide it by 6.022, you get this one. And same way liters, if you multiply liters with if you multiply moles with 22.4, you get liters, and if you divide liters by 22.4, you get moles. So these are the formulas. Next you have gram atomic mass. What is this gram atomic mass? It is nothing but atomic mass only. It means 1 gram of atoms. It is mass of 1 gram of atom. It should be 1 mole of atom, sorry, mass of 1 mole of atom. Okay, it's called gram atomic mass of 1 mole, 1 mole of atom. Gram molecular mass means mass of 1 mole of 1 gram of molecule. So mass of 1 molecule, gram molecular mass. And 1 mole of any substance is Na. Atomicity means total number of atoms in a molecule. How many atoms are present in a molecule? So H2, if you take a gas H2, how many atoms are present in that gas? 2, right? So atomicity of the gas is 2. 1 mole of any gaseous substance occupies 22.4 liters at STP or NTP. An empirical formula is the simplest formula. So HO will be the simplest formula of H2O2, because ratio, you need to take the ratio. 2 and 2 will get cancelled, so HO is the formula. Like that you have a limiting reagent. So basically it's like this. Okay, so you have one compound which reacts with another compound and forms a product. Two compounds react together and form a product. So how much amount of compound is present? So one compound will be limiting. See, for example, if I show you, one boy plays with one boy, because it's a 2-player game. Okay, so we have some game which is 2-player game, for example. So you need 2 boys to play that game. So 1 and 1 boy, 2 teams. In each team there will be 1 boy. 1 plus 1 gives 2, right? So now if I have 1 plus 2, maximum people can play is 2 only, right? 2, 4, 8, multiples of 2. So this 1 is the limiting reagent here. Here you need one more person. If there were 2 people here, then it will be a proper team, 4 people team, right? So I'm giving you like this team example, but same way. In terms of chemical reactions also there is same thing. One chemical reactant will be limiting the other chemical reactant. So one chemical reactant is less. It's not allowing more compound to form. So that is called limiting reagent. The reactant which gets completely consumed in a reaction. So one reactant gets completely used up in the reaction. Another is excess. One gets used completely. So that is called the limiting reagent. And what is Dulong-Pettit law? It specifies about the specific heat. So if you divide 6.4 by specific heat, you get atomic mass. And what is law of conservation? Law of conservation tells us that mass remains same. So if I take a piece of paper and if I burn it, and I have a closed container, if I burn it in closed container, you know that the paper becomes smoke. Do you think that the mass of the paper reduces? No. If you see the overall smoke, whatever smoke is formed and whatever ash is formed, if you add everything, the total value remains same. The total mass is conserved. In reality, why does the mass reduce? Because it forms carbon dioxide and carbon dioxide escapes. But if you don't allow the carbon dioxide to escape after burning the paper, if you take the mass of the carbon dioxide and the mass of the ash, the mass is constant. Okay, so same thing happens in chemical reaction. So mass is always same. And law of constant composition. What does law of constant composition take? So this is law of mass conservation, and you have law of constant composition. So ratio of elements in a molecule does not change. Wherever any part of the world you go, H2O will be same. 2 atoms of hydrogen and 1 atom of oxygen will be there to form water, right? So mass of water is same wherever you go, molecular mass. The ratio of the elements in a molecule, they don't change everywhere. And Avogadro law tells us that volume of gases at equal temperature and pressure have equal number of molecules. So that is STP, what you studied. Volume of equal number of gases. If we take 2 gases at same volume, they will have same number of atoms. And then you have atomic structure. So this is again another very interesting chapter. How does an atom look? So initially we didn't have this. It's very difficult to see an atom, right? So the people used to give their imaginary. How does an atom look? Initially people used to imagine. So different people came and they gave different models of the atom. So there was the person called Thomson. This Thomson told us the plum pudding model. What he told? He told us that atom is like a watermelon and it has seeds embedded in it, electrons embedded in it. So it is a positively charged atom. So the whole thing is positive charged. Entire thing is positively charged, and seeds are like seeds in watermelon. How watermelon has seeds, like that seeds are present, and those seeds are electrons. Like that he gave a model. So drawback was he couldn't explain the stability. How will the electrons stay inside this positive charge? Why they are embedded? He couldn't tell the stability of the atom. He did not show the movement of electrons. He couldn't show about the movement of electrons. He told they're embedded. Right, he didn't tell about the movement. And Rutherford's atomic model, he gave a scattering experiment. He did a scattering experiment. He took a gold foil. He hit the alpha particles which are positively charged. Alpha particles got deviated. Why the alpha particles will get deviated? Because there has to be some positive charge in that, which is repelling the alpha particles. Like that he gave. So basically, he took a sheet of paper. He bombarded it with alpha particles. Alpha particles got deflected in different directions. Okay, and some alpha particles from the middle rebounded from the same place. So that means atom is having center nucleus, very small nucleus. because of which alpha particles are getting going back, and some particles are passing through this piece of paper in different directions. They're getting going away, and majority of the particles pass through it undeflected. That means most of the atom is empty. And then Bohr's atomic model. What did Bohr's atomic model tell us? Bohr's atomic model Bohr's atomic model tells us that it's applicable only for single electronic species. He told that in center there's positive charge and around that electrons are revolving. So basically what structure you study of the atom. He gave a similar structure, but he told only for single electronic species. And then you have this one. You can look here. How do you represent an atom? You write X and up you have A. A means mass number. Z means number of protons. Okay. Z means atomic number. Atomic number. Atoms number. Okay. Atomic number means atoms number. You can remember it like that. Atoms number means every atom has a number. So that is atomic number. Every atom has a fixed number of protons. And what is mass number? Mass number means total. If you add the atoms, that is protons and neutrons, you get the mass number. And this is the chemical symbol. So carbon, for example, it has 6 number of protons. It has 6 protons and total 6 neutrons. So it has 12 number of protons. And so this can be called as nucleons. So how many nucleons it has? 12. Nucleons means whatever is present in the nucleus. Then you have isotopes. What are isotopes? Isotopes are nothing but same number of atoms, same atomic number but different mass number. And isobars are nothing but the same mass number but different atomic number. Isotones are same number of neutrons. Isoelectronic species are same number of electrons. Like this, you have different. Okay. Then electromagnetic waves. Electromagnetic waves are nothing but you have like this electromagnetic wave. So it has alternating electric field. This is electric field, for example, and away from that, it also has magnetic field. Okay. So it will have a magnetic field also. It has two: electric field, oscillating, and magnetic field. So that together forms an electromagnetic wave. That's why the name electromagnetic, EM waves. Okay. And then you know the symbol of wavelength. Wavelength is lambda and wave number is this symbol you use, nu, and velocity is equal to c into f. What is wave number? Wave number is number of waves in a unit length of if you take 1 meter wave, in 1 meter how many number of 1 centimeter if you take, or 1 meter if you take, there how many waves are there? That is called wave number. And wavelength is number of waves in 1 meter in unit length. Okay. And then you have velocity is equal to velocity of the wave is equal to speed of light into frequency of the wave. Okay. So next you have energy. Energy is equal to hc by lambda. H is nothing but 6.626 Planck's constant. H is called Planck's constant. It's 6.626 into 10 power minus 34 joules per second. And Planck's quantum theory tells that body emits radiations in small discrete packets called quantums. Then you have master formulas. So some few formulas are there. Mvr is equal to nh by 2 pi. Mass into velocity into radius is equal to nh by 2 pi. This is angular momentum. Basically, that is equal to nh by 2 pi. N means which shell you are talking about. H is Planck's constant and divided by 2 pi. R is the radius. So for radius, you have formula n square by z. 0.529 into n square by z. Radius of nth orbit. So there are many orbits, right? Nth orbit radius is how much? All this Bohr gave. Okay. So velocity of nth orbit is this much. 2.18 into 10 power 6 z by n meter per second. Velocity unit is meter per second. And energy of any orbit will be energy of n2 minus energy. If an electron is jumping from one orbit to another, what is the energy released by it? Will be n2 minus n1. When it goes to second shell energy minus first shell energy, that will be equal to h nu, frequency of the radiation. Then energy of an electron in the nth orbit is minus 13.6 z square by n square electron volt per atom. And potential energy is 2 times of total energy. And kinetic energy is negative of total energy. Okay, you need to remember that. And 1 by lambda is r into z square. R value is this much. So spectral lines, when the electrons are jumping from different shells, so I can represent these as shells. Okay, so first shell, second shell, third shell, fourth shell. Instead of representing in circular, I'm representing in the form of a line because we have zoomed it and it looks almost straight. So electron can jump to one shell. It has different possibilities, right? So electron can jump from this orbit, this different shells it can jump. From n is equal to 2 to n is equal to 1, n is equal to 3 to n is equal to 1, like that it can jump in different shells. So first it forms different series when it is jumping. It is called Balmer series, Paschen series, bracket series, Pfund series. When it jumps, it releases some energy. That energy lies in visible region means it is Balmer. When it lies in Paschen, it is infrared. When it lies in bracket, it is far infrared. Pfund is far infrared, like that. It has different, okay, near infrared and far infrared. So number of lines, how many lines will be formed? That is n2 minus n1 into n2 minus n1 plus 1 by 2. And dual nature. These are applicable only for single electron species. That is hydrogen-like atoms. And de Broglie's wavelength is E. What are single electron species? Hydrogen is single electron species. Helium. From helium, if you remove 2 electrons, if you remove 2 electrons, then it is single electron species. Like that. So 1 electron, if you remove, it will have 1 more electron, right? So When you remove lithium, if you remove 3 electrons, 2 electrons, lithium 2 plus, yes, Li 2 plus is single electron species, like that. Okay, then you have different numbers to represent. It's like address. So when you talk about your house, if I ask you the address of your house, you will tell it is house number this much, then it comes in this area, that place, then you will tell the city, then you will tell the country, India, right, like that. So principal quantum number is like the country, India, like that. You have different countries, 1 2 3 4. So there are possible values. N has different values, 1 2 3 4. Angular quantum number, that is L, which is 0 1 2 3 4. It comes up to n minus 1. So it starts from 0 and it goes on to n minus 1. And magnetic quantum number, is minus L2 plus L. So if the L value for you is 1, magnetic quantum number for L value 1 will be minus 1 0 plus 1, like that. And spin quantum number will be plus half and minus half. Orbital angular momentum is nothing but L into L plus 1 into h by 2 pi. That is the formula. And then you have number of electrons in subshell. Then you have total number of nodes, that is n minus 1, like that. And next you have classification of elements and their periodicity. So what is classification of elements? So when you want to represent elements, you represent them in this periodic table. So I suggest all of you to learn this entire periodic table, because periodic table learning is very important for your examination. So in terms of different groups you can learn. First group elements, these are groups, okay? First group, second group, third group, fourth group, fifth group, sixth group, like that. And these are periods: first period, second period, third period, fourth period, fifth period, sixth period, seventh period, like that. So groups wise you can learn: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, iridium. Then you have scandium, yttrium, lanthanum, actinium. So these are lanthanides and actinides. They are placed separately, these two, okay? And titanium, zirconium, hafnium, vanadium, niobium, tantalum, chromium, molybdenum, tungsten, manganese, technetium, rhenium, iron, ruthenium, osmium, cobalt, rhodium, iridium, nickel, palladium, platinum, copper, silver, gold, zinc, cadmium, mercury, boron, aluminum, gallium, indium, thallium, carbon, silicon, germanium, tin, lead. So here if you go right words, if you go from one group to another group, the electron gain enthalpy increases and ionization energy increases. If you go upwards, your electronegativity increases. If you go downward, atomic radius increases. And if you go this side, non-metallic character increases. If you go this side, metallic character increases. And ionization enthalpy increases upward, electron gain enthalpy increases. And if you go this side, electronegativity increases. If you go this side, atomic radius increases. So as you go right side, atomic radius decreases because more number of atoms are added, and because of that there is more attraction, and the size of the atom decreases. Then you have S block elements, that is NS1 to 2. P block elements is NS2, NP1, 1 to 6, and D block elements are N minus 1, D 1 to 10, and NS1 to 2, and these are F block elements. So these are metals, these are metalloids, these are metals, these are radioactive elements. Then you have states of matter. You have different states of matter: solid, liquid, and gas. And plasma is not very important to you. So solid melting and liquid on vaporization forms gas, and gas on ionization forms plasma. Then solid on plasma on deionization forms gas, gas on condensation forms liquid, liquid on freezing forms solid. Okay, this side you heat it, this side when you cool it, it goes this side. Then you have different types of forces. Okay, so different types of forces are dipole, dipole, ion induced dipole, dispersion, London forces, hydrogen bonding, van der Waals forces. So dipole means what? So two atoms are there, for example, two more atoms. Between that there will be charge separation. Charge gets separated, positive and negative. Because of that there is an attraction. This positive side attracts the negative side, and if positive is there, they repel each other. So these are dipole forces. And ion induced dipole means if there is an ion, if you take an ion near a neutral atom, that neutral atom charges get separated. This side towards the positive ion, negative charge comes, and because of that there is an attraction, and that's why there is positive, and this positive side is attracted with some negative atom there. Okay, like that. So it forms like that bonds. Then you have ion dipole forces. Anion forms with polar bond, and cation, again polar molecule with negative side, it joins positive charge element. So next you have London dispersion forces, and even distribution of electrons is there. Because of that, instantaneous dipole and induced dipole on neighboring helium. So on neighboring helium there will be induced dipole. And then you have this Boyle's law: P1 V1 is equal to P2 V2. So you can see the graphs here. Boyle's law graph is like this. With pressure, this thing reduces. Okay, pressure reduces as you increase the volume, and here volume increases when you increase the temperature, and here again pressure increases as you increase the temperature. Gay-Lussac's law. So next you have ideal gas law: PV is equal to nRT. So this one thing is very important, and different laws. Charles law applies when what is constant at constant pressure. Gay-Lussac's law at constant volume. So from this term you can make one thing constant. P is constant means P will go. Okay, from here, then what is proportional to what? Volume is proportional to temperature, like that. You can see the graphs and you can understand it. Then these are again another formulas. Average kinetic energy of 1 mole of gas is 3 by 2 RT. Average kinetic energy per mole of gas is this much. Average speed is this much. Most probable speed is this thing. And V MPS, V average, RMS is this is the ratio. Then you have real gas do not follow kinetic theory of gas. Only ideal gases will follow. Real gases don't follow. At low pressure and high temperature, real gases behave as ideal gas. And Z is equal to PV by nRT. Z is equal to 1, it is ideal gas. So you can see Z is equal to 1 means PV becomes equal to nRT. So then it is that ideal gas equation. So it's an ideal gas. And if it's greater than S, do not follow ideal gas equation. Positive deviation it is called. And in this case situation, it is called negative deviation when Z is less than 1. Then next you have van der Waals equation. Van der Waals equation tells us P plus A n square by V square into V minus NB is equal to nRT. So this is van der Waals equation. Then here temperature, and critical pressure, you can see the formula. Thermodynamics. So this is again very important chapter. Thermodynamics is a study of heat, flow of heat. Dynamics, right? Dynamics means something movement, and thermo means study of heat. So there are different types of system: open system, closed system, isolated system. So what is open system? Open system is a system where heat and energy and matter both can be exchanged. So here gases, that is mass, also can escape, and heat also can move. And here only energy can move, mass cannot move. That is called closed system. You cannot add anything or you cannot remove anything from there. Only heat can be removed, energy. And in this situation, energy also cannot be moved, and mass also cannot be moved. The path function are the function which depend on the initial and final states. Intensive properties are example, density, specific heat and all. So you can see example, path function example is work and heat. Intensive properties are independent of mass, they don't depend on mass, example density and specific heat. Boiling point and melting point. Extensive properties are this mass, volume, Gibbs free energy, entropy, all these. They are dependent on mass, extensive properties. So have different type of thermodynamic process. You can see isothermal process, isobaric process, isochoric process. So the isothermal process graph you can see, isobaric graph you can see, and isochoric graph you can see. Isothermal means constant temperature, isobaric means constant pressure, isochoric means constant volume. So all the situation, how the graph reacts, you can see. Then you have types of thermodynamic processes: reversible, irreversible. Types can be illustrated as isothermal, isobaric, isochoric, what I told you. So you can see constant pressure, isobaric, constant volume, whatever I told you. And delta E plus is equal to Q plus W. Q is heat, okay? So delta E is heat supply, delta Q is heat supplied or rejected plus work done. So heat plus work done gives you the change in internal energy. And then second law of thermodynamics, this is first law, okay? Change in internal energy is equal to the heat supplied or removed plus the work done on the system. And second law of thermodynamics tells that change in Gibbs free energy is equal to delta H, that is change in enthalpy, plus T into temperature into delta S. And you can look at the formula, same formulas are given here. So isobaric process, what happens? Isochoric process, what happens? Then what happens in case of cyclic process? All those you can see. And enthalpy formula I can see P plus delta V, which is equal to this thing, and delta E plus NGRT. And work done in different processes is reversible isothermal process. Work done will be equal to this much. So you have this formula, and closed vessel, then free expansion of ideal gas. Then entropy formula, you have entropy is randomness in the system, okay? So change in entropy is heat with proper sign convention you need to follow, and divided by temperature in Kelvin. And chemical reaction is like this. So these are the product, these are the reactants. When you need to subtract both, you will get the delta S. Change in entropy for isothermal process, you can see isochoric process. So equilibrium, you have equilibrium is reactants form products and products form reactants also. So generally we see reactants will react together and form product, but at equilibrium what happens? Both the concentration becomes equal, the formation of reactant and product. So products also start to separate and form reactant. So both the side. So forward reaction and reverse reaction is equal. That is called equilibrium. So you can see here equilibrium formulas. To achieve equilibrium, reaction should be in closed container. Then rate of equilibrium is this much. Rate of forward reaction, rate of backward reaction is represented there in equilibrium. So you can see the graph. Law of mass action is called LOMA also, law of mass action. Active mass is equal to number of moles of a substance divided by volume of liter. Then active mass of solid and liquid is 1. Active mass of any substance in excess is so you can see 1. Then you have law of chemical equilibrium. So Kc, chemical constant, equilibrium constant, you can see that will be equal to the power of this one. Here whatever number of moles you had, you need to take the concentration of that and take it to the power of this one. And for gaseous equation it is this much. You can see all those. And whenever you need to find it, you need to equate, you need to add both the equations, and you need to cancel one term here. So just like how we used to do in mathematics, like that. And Van Hoff reaction, you have negative temperature, all those. Le Chatelier's principle, you have what Le Chatelier's principle tells us: concentration. If you increase the concentration, it favors product formation. Reaction will be forward reaction. And if you increase the product concentration, it comes backward reaction. Reaction will be backward. If you increase the temperature, whichever is endothermic reaction, it favors that. If you decrease the temperature, it favors exothermic reaction. If you increase the pressure, it favors the side with fewer molecules. If you increase pressure, which side less molecules are there, it tries to go that side. If you reduce the pressure, it favors the molecules with more. So that's it. Thank you very much. And do like if you want to learn more, and if you want me to teach you the question and answers and other things, please do subscribe to the channel. And thank you very much.